Dear students, in this video we are going to see the experiment number 2, feature selection and feature extraction for the lab 20CS2032L machine learning techniques. The steps we are going to implement in the experiment number 2. First, we are going to import the necessary libraries. Next, we have to read the input data. And we have to do some feature selection techniques and also feature extraction technique. Since the data whatever we collected from the real world is a raw data. If you want to use these data to a machine learning model, we need to use with the feature engineering technique. So we need to extract some meaningful features in terms of feature selection and feature extraction so that it will be given to your machine learning model to produce the targeted output. And before going inside for the feature selection and feature extraction, first we have to know what is meant by feature. So the feature represents characteristics of your data. Feature represent characteristics of the data. So this is our data set. We have various instances available and we have these column names. So these column names represents features. So since to identify a particular type of output, so here the fruit name is my target. So to identify the target, this will be identified based on some input features. So the characteristics. So if I want to identify an apple, so the apple should have some characteristics. So the mass value, width value, height value and the color score. So based on these input features, the output feature, that is the target, can be predicted. So in our real world we have lot of data. So these data, maybe you may have one-dimensional data, two-dimensional data, three-dimensional data. But in real time we have high-dimensional data. So these data are extremely complex to process because due to its inconsistencies available in the data and it is collected from various sources, it will increase the computational complexity. So this problem is called as curse of dimensionality. So if I want to search a particular point in a one dimension, it is very easy. So I can move from here and I can easily find. If I have a point in the two-dimensional data, then I have to go with x direction, y direction, x direction, y direction. So like that I will move and search that particular point. If it is a three-dimensional data, again I need to use with x coordinate, y coordinate and z. So like that I move step by step and finally I will try to reach the particular point. But in a real world, the dimension of your data is high dimensional. So it is an n dimension. Okay, so in that case, so we have lot of features. So but that all features are not going to contribute to your target output. So we need to reduce these features. The feature reduction can be implemented in two ways, that is by using feature selection and the feature extraction. So to work with your machine learning model, the first basic step, basically we divide our data into two parts. That is the training data set and the testing data set. So based on your training data set, the model gets trained. And once the model gets trained, the model will be tested by using the testing data set. So to divide your data into training and the testing set, in the scikit-learn library itself, we have a function called as train test split. So the train test split, we need to pass the input data frame, that is your input data, what you want to split, and the test size. So basically the data will be divided into 80-20. So 80% will be used for training purpose and 20% used for testing purpose. And then we have another one parameter called as random state, because out of your input data you are selecting some 80% for training and 20% for testing. So every time you run the algorithm, it will randomly take the training and testing. So your output will not be in a common format. That is, it will not be having a same value every time. So to make your training and testing is reproducible, so every time when you run the algorithm, the same set of instances has to be taken for the training and the testing set. So you need to give the random state value. So when you apply this training and testing split, at the end you will get a set of training data and the set of testing data with 80% of the data and the 20% of the data. And next we are coming to the main part of our experiment, that is the feature selection. So what is meant by feature selection? So feature selection is a process of selecting the subset of the relevant features from the original features. Maybe you have your original features, that is you may have some 100 columns. So these 100 columns are not going to provide a direct effect on your target output. So some of the columns are inconsistent. So you don't want to use that in your machine learning model. So for that time you need to select which are all the features are more efficient to support your target. So that features are identified and that will be taken as a relevant feature. So maybe some 75 features are enough to train with your machine learning model. So out of 100 columns or 100 features, we are handpicking some subset of relevant features, that is producing a good output for your machine learning model. So how we are going to identify that relevant features? So that we are going to use with some of the standard feature selection techniques. So these are the feature selection methods we are going to implement in our experiment number 2. We are going to remove the unused columns, remove the column with outlier, remove the features or columns with missing values, remove the columns with low variance, remove the uncorrelated features with the target, and remove the high correlated features, that is multi-collinearity features. And then by using the univariate feature selection, it is one statistical method. By using the statistical analysis, how we are going to reduce the features, and finally the information gain based feature selection. The first one is removing the unused columns. So for example, you may have some data set. Okay, so in the particular data set, the outcome of your data set is price. So these data doesn't need the information about the first name and last name and the address of the person. So that information may not be relevant to this output target feature. So in this case, the columns whichever is not relevant to the target, that can be removed. So the remove can be done by using the Python method called as drop, whichever columns you are feeling it is not relevant to the machine learning model to use. Then you can specify the column names here. The axis 1 represents I am going to drop the particular column. So I am putting axis equal to 1. And then remove the column with outliers. You know what is meant by outliers. And basically how you can identify the outliers. The outliers will be identified that in a particular numerical column, if the mean value is less than the median value, then we may have outliers in that particular column. So that column you need to identify first. So how will you identify the columns first? So first you need to use a select_d type methods. So this will take only the numerical columns. Okay, numerical columns. And from the column, whichever retrieved as a numerical column, you use a for loop. And for each column, you take the mean value and median value. Check the mean value is less than the median value. You identify that particular column first. Identify the column with this constraint. And next, you drop the column. So next, the third method, removing the features with missing value. So if a particular column having most of the values are null values, that is 80% of the data is null value. So if you are doing any data imputation, so then it is wastage. Okay, and we have set some constraint here. If a particular column having greater than 20% of missing value, don't go for data imputation, just drop the column. So the basic idea is if you have less than 20% of missing value, you can go for data imputation. If you have more null values, if you do data imputation also, so that will mislead your machine learning model. So to avoid that, if a particular column having greater than 20% of missing value, so just drop the particular column. So you know how to identify the missing values. So that will use with the is null method. and you take the percentage by calculating the mean of that particular null values, and you can calculate the percentage. So if the percentage goes above 20%, so just drop that particular numerical column, that particular feature column, and remove the feature with low variance. So this also you can apply for the numerical columns. You identify all the numerical columns. For every column, calculate the variance. Okay. So out of all the numerical columns which have the low variance, or you may set some threshold. If the variance is less than the particular threshold, you just drop the columns. Just drop the column. Select for every column, calculate the variance, set some threshold value. If the threshold value or your variance is less than that particular threshold, drop the particular column. And the next way is you can remove the uncorrelated features with your target. So that also based on some target values or some threshold values, you can drop that uncorrelated features. Okay. So you know that the core function will find out the correlation between every value. And now I am trying to find the correlation between my target. So all my input features are how it is correlated with my target. So I need to calculate that. And I need to identify which are all the input features are correlated less than 0.2. So that not going to give more effect on my target variable. So that columns I can easily drop. So when you see this figure, you can see I have a condition. Whoever having that correlation value is less than 0.2. So I can test with the symbolic. So the price is my target. So for the target feature, these are my input features. So these are my input features. So how these input features are correlated with my target. So by comparing here, symboling is providing less than 0.2 correlation with my target. So I can drop it. And the compression ratio also, I have less than 0.2 correlation. So I can drop it, that particular column. So I can identify this column and this column using this correlation function with the particular target output. So put the threshold value. So whoever having the correlation with the target is less than 0.2, identify that particular column and drop the column. And next is we need to remove the highly correlated features. Okay. So you know the core function will give the correlation between every two inputs, and you can use a heat map to visualize this correlation matrix. So out of this heat map, for example, I am identifying this value. Okay. So this value represents it is highly correlated because it is a positive value. So the length and the weight is highly correlated with the value of 0.88. So it is a positive correlation. So if I increase weight, automatically the length will increase. So if two independent variables are highly correlated, instead of using the two independent variables for my machine learning model, I can drop any one of them. That is, out of this highly correlated features, I need to remove any one. So I need to identify which thing I need to drop it. So first I need to identify the highest correlated value. After identifying the highest correlated value, out of these two independent features, which feature need to be dropped. So here also my target is price. Okay. So now I need to check how these two independent attributes contributing to the target. So when I come with weight is contributing 0.84 with the price, and length is contributing with 0.7. So by comparing these two, weight is highly contributing than length. So I can drop the length feature. I can keep only the weight feature because two features are highly correlated positively. So instead of keeping both the features for my machine learning model, I can keep only one features out of the two highly correlated features. And next is the univariate feature selection. It is one of the statistical tests which will help you to identify the features that have a strong relationship with the target feature. So the independent features are nothing but your input features. So by using some statistical measure, you need to identify which are all the independent features are more correlated with the target features. So to identify that, in the scikit-learn library, we have a function called as select the k-best. So select the k-best input features which are more relationship with the target variable. So to identify the k-best input features, we can use some statistical test. So here the statistical test used is the chi-square test. So using the chi-square test for every input variables or for every input features, so how it have a relationship with the output variable, it will be calculated by the chi-square statistical measure, and out of that you need to select the features which is having the, so I am going to select the best 10. So out of n, I am going to select the best 10 input feature that are having a higher relationship with the output feature based on the statistical measure chi-square test. And next is information gain based. So this will calculate the mutual information about of each independent variable depends on our dependent variable. So how every independent variable is mutually having a relationship with the dependent variable. So that I will identify which are all the input features having the most information gain. Okay, most information gain with the corresponding output variable. So you have your input variable, you need to identify the most information gain to the target variable. So out of your n input features, you may have some of the features only having the most information gain related with your target variable. So it will return the feature score for every features, okay, it will return the score, the mutual score with the target. So from that you need to identify the highest mutual or most information gain feature you will identify, and that feature you keep, the other features you can drop it. And next thing is you can do the feature reduction by the technique called as feature extraction. Now what is the difference between feature selection and feature extraction? So feature selection means from the given n features we are selecting the subset of features. Okay, and what is meant by feature extraction? So feature extraction is a process of transforming the original feature into a new set of features by applying some transformations. Okay, so that this new set of feature also maintain the same information from the original set of features. So if I apply this new set of features to my machine learning model, instead of giving a direct input features, I transform it, and the new set of feature I apply to the machine learning model, it will yield the better result. So to apply that, you have PCA, then you have LDA, linear discriminant analysis, then you have the principal component analysis. So there are several methods available in this way. Here we are going to discuss with PCA and LDA. So first one is the principal component analysis. So principal component analysis is a unsupervised dimensionality reduction technique, so which will allow you to identify the correlations and the patterns available in your original data set, so that it will be transformed into a new set of data set which is having a lower dimension, and also it having all the important information from your original data. You may think, if I do the dimensionality reduction, there may be a loss of data, but when I am using a PCA, the original data is transformed into a new set of features in a lower dimension, but without the loss of information gain. So in order to do that, we have to follow some steps. So here, this PCA, we are not going to use the built-in Python function. So instead of that, you need to hard code the Python code step by step. Hard code the Python script step by step. So first you need to read the data. After reading the data, we need to standardize. So why we need to standardize? If you see here, this is one feature and this is one feature. And these feature having a range of the values 1 to 5. And these feature having a range of values from 300 to 1300. So the range of value is different. So to make all your data into a similar range, okay, scaling your data into a similar range, you need to do the standardization. So first you do the Z-score standardization. So for every column, calculate the mean standard deviation, and for every value, just do the value minus mean divided by standard deviation. So all values will be coming to the range of 0 to 1. So it get normalized. And then the next step is computing the covariance matrix. The covariance matrix gives the correlation between different variables in your data set. Suppose you have 2 features, means then your covariance matrix is 2 cross 2. Suppose you have 10 features, means the covariance matrix is 10 cross 10. So I have 2 features, feature A and feature B, feature A and feature B. So everything here will be given the correlation between the features A and A. Correlation between the features A and B. So if it is positive, then A and B are highly correlated. If it is negative and A and B is, if it is positive, so it is a direct correlation. Okay, so directly they are correlated. If I increase one, automatically the other also increase. Negative correlation is a indirect correlation between the 2 variables. The next step is calculating the eigenvectors and the eigenvalue for the covariance matrix, because these eigenvalues and the eigenvectors only determine the principal components of your data set. The principal component represents the new features what you get from your original set of features. And after calculating the eigenvectors, you need to compute the principal components. You have to sort the eigenvalues and the eigenvectors, and whichever having the highest eigenvalue, that is the first principal component. For example, if I have 5 features, I will get 5 PCA. So in that, the PCA which is having the highest eigenvalue, that is having most or maximum possible information when compared with the second PCA component. Okay, so this is the thing, we need to compute the principal components, and based on these principal component, you need to select which principal components you need. For example, I need only the first 2 principal components for my machine learning model, means so you have to rearrange the original data, and based on the best principal component, you select that particular components alone. That will be given as an input for your machine learning model. So I will show you the script of the Python so that you can use it to implement your PCA to do the step-by-step procedure for the feature extraction. So first step is standardization of the data. Once you get your data, get the data, then split the data, and the another one thing. So whatever feature extraction, feature selection you are using for your training data, that need to be applied for your testing data also. Okay. So first read the data, next split the data. Now we need to standardize your data. So by using the standard scalar available in your sklearn, we have standardized your data. After standardizing, the next step is calculating the covariance matrix. So for the standardized data, we are calculating the covariance matrix. So every feature here, how it is correlated with feature here. So based on the correlation matrix, we need to calculate the eigenvalues and the eigenvectors. So this is also available in your NumPy library. Using that, you can calculate your eigenvalues and eigenvectors. And then you need to sort it and identify which eigenvalue is the highest eigenvalue. So that represents the first principal component for your input data. So sort it, your eigenvalue and the eigenvector sorted. And from that, the best 2 principal components I want to select. So I am specifying out of this eigenvector, the best 2 having the highest eigenvalues I need to select. So out of all the eigenvalues, I am selecting the best 2 PCA. So I told that already, the first PCA having the more information than the second PCA. It is a next level, like that all. So I can able to know that instead of sending all my n features, If I pass this to PCA feature component itself, I can able to do the same, or I can get the good result for my machine learning model. And next is reducing the data set, because previously it has this data having n features. And now we have selected some eigenvectors which is having the highest PCA value. So based on that PCA component, we are reducing our n input features into 2 PCA components. It having only 2 PCA components which will be given to your machine learning model for further processing. So that I am converting as a, in order to visualize it, I am taking only the 2 components and I am forming as a data frame. And then I am attaching, because in my original data I am having n number of features and along with my target. So now it is reduced using my feature extraction technique. I have only PC1, PC2 and the target. Okay, I have only 3 columns. Instead of passing all these information, high dimensional data to my machine learning model, now I am selecting only the principal components from my input data set. That alone I am sending to my machine learning model. So automatically the complexity of my model get reduced. Okay, so to visualize it, use the scatter plot and visualize how the principal component is contributing to your target, so that you can view it in the scatter plot. And the next methodology is the linear discriminant analysis. And PCA, I told it is an unsupervised dimensionality reduction, but LDA is the supervised dimensionality reduction, because whenever I use PCA, I am not considering my target column. But when I use my LDA, so the feature extraction will be done by considering the input feature and also by using the output features. So PCA does not use the output target variable, but LDA reduce the dimension by retaining the informations that discriminate your output classes, because it mainly work based on within class and between class. Okay, so to consider that the target variable also needed for the LDA to perform the feature selection. So here also it is using some of the steps, computing within class matter and between class matter, and then from that you calculate the eigenvalues, eigenvectors, then calculate the top k values, and based on that you can reduce your further feature reduction and select the new set of features. And here, instead of doing this LDA, we are directly using the scikit library. Okay, scikit-learn library itself, directly use it. Here no need to hard code the Python step or step by step. So first step is convert your data into standardization. Next, to use with LDA, you need to import the linear discriminant analysis, and I am going to tell out of n features I need to select only one component. Okay, so maybe my input having n features, now my output having only one LDA component and along with target. So it is a feature reduction technique based on supervised learning method, because we are calculating the within class variance, between class variance, and to calculate the LDA we are considering the target also, because you see here the input also we consider, the target also we consider. So it is working based on the how your new feature set can able to better discriminate your target value. So that features you are retrieving in your LDA component. And the last thing, can I extract? So far you have used is the numerical data in an Excel sheet or the CSV file. So how I can extract the features from an image? Because image is also like your 2D matrix. So if you want to read any images, so if it is a grayscale image, it is a single matrix, n cross n matrix. And if it is a color image, it will be viewed as the 3 matrix. So which will be, so this is actually your image. So whenever you read the image, it will be having 3 components. So red component, green component and the blue component. So every pixel here represents the intensity value of the particular pixel. Okay, so these intensity values are range from 0 to 255 to represent a particular color in that particular pixel location. Okay, so how you can do the feature extraction here? Here I am going to use this simple feature extraction, that is the mean feature extraction. How I am going to calculate the mean feature extraction? So the mean feature extraction means, so this will be represent, so you know that it's a two-dimensional matrix. It's a two-dimensional matrix. So maybe it having a size of 150 cross 150. Okay, 150 cross 150. So you can use a for loop, outer for loop to represent the row of the image, and inner for loop represents the column of the image. And I have three components. So first component will be represented with 0, red. This will be represented with green, and this will be represented with blue. Okay, so every pixel how I will take? So this is an image. I will take the I, that is a row, then column and the red component. So like that I will take with blue component, I comma j comma 1, and then green component, image I comma j comma 2. Okay, so it is a mean feature extraction. So add everything, divide by 3. So that I will store it in a new matrix. So this is the corresponding feature extracted from this input image. This is your input image. From that we have extracted a mean features out of this R, G and B. Okay, so this will help you how to read an image. So we need to use with the library skimage.io. Read the image by giving the file name. If I want to show the image, I can use the IamShow. Now this image will be acting as a two-dimensional matrix with three components R, G, B. So when I display the size, it will display 150, 150, 3. Okay, this is your row, this is your column, and then this represents your channel. Okay, so I think this video is useful for you to know about what is a feature reduction mechanism, how you can reduce the feature by using the feature selection and feature extraction, so that you can use these concepts to complete your experiment number 2. Thank you.